Foundations of Amateur Radio. If you've been following my amateur radio journey, you'll have likely noticed that I've been straying from the fold. The words I use for power have been changing. I've reduced references to watt and increased use of the term decibel. Initially this was incidental. Recently it's been more of a deliberate decision, and I'd like to explain how this came to be. It starts with representing really big and really small numbers. Let's start big. On 14 September 2015, the first direct observation of gravitational waves was made when a pair of black holes with a combined estimated weight of 65 solar masses merged. The signal was named Golf Whiskey 150914, combining gravitational wave and the observation date to immortalise the event. Following the collision, it was estimated that the radiated energy from the resulting gravitational waves was 50 times the combined power output of all the light from all the stars in the observable universe. As a number in watts, that's 36 followed by 48 zeros. If you're curious, there's even a word for that: 36 Quindecillion Watts. Now let's look at small. The typical signal strength received from a GPS satellite, like say by your phone, is about 178 attowatts, or in watts 0.000 and so on, in all 13 zeros, between the decimal point and then 178. What if I told you that the energy associated with the collision of those two black holes could be expressed in comparison with a milliwatt? Remember, this collision emitted more energy than all the output of light from all the stars in the observable universe. The expression for all that power is 526 dBm. Similarly, the tiny received GPS signal can be expressed as minus 127.5 dBm. Just let that sink in. All the power in the observable universe through to the minuscule power received by the GPS in your phone, all expressed between 526 dBm and minus 127.5 dBm, and not a zero in sight. As I mentioned, the unit dBm relates to a milliwatt. As a starting point, let me tell you that 1 watt is 1000 milliwatts and is represented by 30 dBm. The decibel scale doesn't work quite the same as other number ranges you might be used to. Adding the value 3 doubles its size, and adding the value 10 increases its size by a factor 10. For example, to double power from 1 watt or 30 dBm, add 3 and get 33 dBm, which is the same as 2 watts. If you want to increase 1 watt by a factor 10, again starting with 30 dBm, add 10 and get 40 dBm, which is 10 watts. Similarly, 50 dBm is 100 watts and 60 dBm is 1000 watts. Going the other way, halving power, remove 3. So, taking 3 from 60 dBm is 500 watts, or 57 dBm. Dividing power by a factor 10 works the same. Take 10. So, 47 dBm is 50 watts and 37 dBm is 5 watts. If you get lost, remember dBm relates to a milliwatt. 1 watt is 1000 milliwatts and is represented by 30 dBm. Divide by a factor 1000, remove 30, and end up with 0 dBm, which is the same as 1 milliwatt. I'll say that again. 0 dBm is the same as 1 milliwatt. It takes a little getting used to, but you can do some nifty things. For example, remove 10 to get a tenth of a milliwatt, or minus 10 dBm. The same process of adding and subtracting applies in other ways too. Attenuation, or making a signal weaker, and amplification, or making a signal stronger, can use the same rules. For example, if you apply 3 dB of attenuation, you're making the signal 3 dB weaker, or halving it, so you subtract 3 dB from your power output. If your amplifier is rated at 6 dB gain, you're quadrupling the output and you add 6 dB to your power output. Similarly, if you talk about the gain of an antenna, you add it. If the gain is 20 dBi, you add it to the power output. You can use this for coax loss calculations as well. A 100-metre length of RG58 at 28 MHz has a loss of 8 dB. You can directly subtract this from the power output of the transmitter and know precisely how much power is making it to the antenna. There's more. The radio amateur S9 signal strength on HF, something which we consider to be a strong signal, can be expressed as -73 dBm, or a very small fraction of a milliwatt. An S8 signal is 6 dB weaker, or -79 dBm. A 20/9 report is -53 dBm. I will point out that this is at 50 ohm. As a result, we now have a continuous scale for all the elements in the transmission chain between the transmitter and the receiver. While I'm here, I've already mentioned that negative dBm readings relate to fractions of a milliwatt, so values between 0 and 1. This highlights one limitation of this scale. We cannot represent 0 watts. Mind you, that doesn't happen all that often. The thermal noise floor in space at 1 Hz bandwidth, that's at 4 kelvins, is -192.5 dBm, which practically means the minimum level of power we need to express. It's also a good value to remember, because if you're doing funky calculations and you end up with a number less than -192.5 dBm, you can pretty much guarantee that you've probably made a boo-boo. 0 watts using the dBm scale is represented by negative infinity, or essentially a division by zero error. Really not defined. So there's that. I'm Ono, Victor Kilo 6, Foxtrot Lima Alpha Bravo.